Hello everyone, this is Tiger again. So let's take a look at the second half of this 2017 paper for the JMC. So we'll be talking about the questions from number 16 to number 25. Let's take a look at what interesting questions we have today, alright? So, getting started with question number 16. So I will say that it is a word problem. Well, clearly it is. And it's a money problem because it's about some currency. And I would also say that it belongs to counting, as in the ordered enumeration. All right. So essentially, why do I think that it is also belonging to the ordered enumeration? That's because, well, it tells us that the smallest number of coins needed to make 13p is 3, and the smallest number of coins needed to make 19p is also 3, right? Which means that essentially if I'm only having 3 types of coins, I can only have 1 extra coin. So I will be using 2, 5 and some other coins to make 13p or 19p, right? With a number of any of them. So it means that I have limited options of the coins. For example, can it be possible that I'm using all 3 of a kind? It's not, right? Because 13 and 19, they are both not multiples of 3. So it means that, well, these are the possibilities. So first of all, I might be just using one of the new coins, right? Which means that it's either going to be 2p adding 5p, 2p adding 2p, or 5p adding 5p, right? If I'm using 1 extra coin. So the values of the extra coins are going to be 12p, 15p, and 9p respectively. But of course, it is still possible that I'm using 2 of the new coins, right? Such that it would be, well, it has to be 5p for the remaining one because it is an odd number. 19 is an odd number. So it means that I'm using 2 7s and a 5. All right, so these are all the possibilities, which means that the values of the new coins can be 12, 15, 9, or 7. Now we just need to know which one of them it is. So I'm just looking at how I can make 13p as well. So 13p can be 2 and 5 and 6. It can also be 2 and 2 and 9. It can also be 5 and 5 and 3. Or it can also be 5 and 4 and 4. These are the only 4 possibilities. So I'm saving the unit because I don't have enough space. So 9, 6, 3, and 4. These are the possibilities. But we know that we just have one value of the new coin, right? So it means that I need to find a value that is happening, like that is showing or possible on both sides. And that goes to 9. So we have the answer 9p. All right? Does it make sense? Okay, so that's it for question number 16. I hope you all understand it. And now let's take a look at question number 17. So this one is pretty easy. It is going to be on numbers and operations. And it's about the arithmetic progressions. First of all, the question says that I'm adding up all the even numbers between 1 and 101, which means that I have 2 adding 4, adding 6, adding 8, all the way till 98 and 100, right? And then I'm subtracting all the odd numbers between 0 and 100. So I'm subtracting 1, subtracting 3, subtracting 5, all the way until I'm subtracting 97. I'm subtracting 99. So you can see that each number I subtract is one less than the corresponding term I add, right? So you can see that for each column, I have one remaining. So how many ones do I have remaining? It would just be the same as the number of terms we have. So from 2 to 100, how many even numbers are there inclusively? So 2 is 2 times 1, 100 is 2 times 50, so it means that there's going to be 50 even numbers altogether, right? So there are 50 terms in both sequences, which means that I have 50 of the ones. So stacking up to 50 of the ones, the answer is definitely going to be 50. Right, so the sum is going to be 50. That's it for question 17. And then for question 18, so I think this is a very interesting question, and it requires you to notice which part of it are you going to start with first. So this belongs to the miscellany questions, and this is a cross number question. So essentially we know that, well, I need a 3-digit cube across 1, and for 2 down it is a 2-digit square. For 3 across it is a power of 11. So there are many cubes that can go into a 3-digit cube, and many squares too. But as for a 5-digit power of 11, I believe there's only one of them. So if you understand the multiplications of 1, or like the powers of 1, the powers of 11, or the multiplications of 11 well enough, then you will see that, well, it's going to have sort of like a pattern. And we can actually read it from the Pascal triangles, if you know what that is. So for example, like 11 to the power 1 is 11. And then to the power 2, it is 1, 2, 1. For power 3, it is 1, 3, 3, 1. For power 4, it is 1, 4, 6, 4, 1. So that's like the layers in the Pascal triangle, if you know what that is. All right. So essentially, you don't need to know what that is, but it's good if you know. And 11 to the power 5. No, 11 to the power 4 is going to be 14641, and that's a 5-digit number. Okay, so that's how we can fill it in, right in there. And then, what next? So the only thing I have now is a 4 in the 2 down, right? Which means that I need a square, a 2-digit square that is ending with a 4. So, of course, it's going to be 64, isn't it? And now I need a 3-digit cube that's ending with a 6. So I've got no choice but to put 6 cubed, that is 216 in there. So that's how I can solve this question. You need to be familiar enough with all the cubes, all the squares, and also you need to know the powers of 11. So if you can memorize all these numbers, congratulations, this is going to be an easy question for you. But if you cannot, well, it's not your fault. But of course, if you can get yourself more familiar with these kinds of numbers, that's also what we call the mathematical sense, like establishing a sense of numbers, like, and then you know what you put in there. So finally, you just need to add up all these digits. So you have 9 in the top row, and you have 16 in the bottom row. So adding 9 to 16, you get 25. All right, that's the sum of all the digits there in the completed cross number. And as for question 19, so I don't think this is a hard one, as long as you will be able to recognize what this TVU is. So essentially, we're just joining T and V such that we are looking for that angle. All right. So we have a regular hexagon which we know that the interior angle is going to be 120 degrees. Oh, wait. Of course, there's going to be a geometry question on the interior and exterior angles. All right. So, for the interior angle of a regular hexagon, if you can memorize that number, it will be great. If not, then you will just need to use the formula to deduce that. But that's definitely going to be pretty much slower. But here I'm just telling you that it is 120 degrees. And for the interior angle of a square, it is 90 degrees. For the interior angle of an equilateral triangle, it is 60 degrees. Which means that the angle TUV, which is that one right there, TUV, is going to be 360 degrees, take away 60 degrees, take away 90 degrees, take away 120 degrees. So that is going to be 90 degrees. All right. So we know that TUV is going to be a right angle. So now we have just made use of the angles, but then we can also see that for equilateral triangles, squares, and regular hexagons, all of their sides has to be the same length, right? Which means that VU is equal to TU, and essentially triangle TUV is isosceles. And for an isosceles triangle, we know that the base angles are the same, which means that this angle TVU will be equal to that angle VTU. All right, so we can calculate the angle TVU by 180 degrees, which is the interior angle sum of triangles. Take away TUV, that's the 90 degrees, divided by 2, because we know that the two base angles are the same. So it's going to be 45 degrees. All right, and A is going to be the answer to this question. That's how we can figure this out. As for question number 20, it is a statistics and probability question, so it belongs to the counting module, and it would be belonging to that section which we call the mean, median, mode, and range. So we need to know the definitions of all these. First of all, the range of a list of integers 20. It means that the largest number take away the smallest number is 20. And it says that the median is 17. So there are two possibilities for a median. When the number of numbers is an odd number, then the median is just the number in the middle. If the number of numbers is an even number, then the median is just going to be the two middle numbers added up divided by 2. So it means that if I want a median, I would just need one number at least. But if I want a range, I would need two numbers at least. All right, so that's the reason why we have the maximum number and the minimum number, the two numbers at least. So now, let's see if it is possible to just have two numbers and we can make a median of 17. So it means that the two numbers added up divided by 2 is equal to 17, which means that their sum is going to be 34. So now it becomes a sum difference problem. For the two numbers, the sum is 34 and the difference is 20. So we know that the larger number is equal to 20 adding 34 divided by 2, that is 27. And the smaller number is going to be 34 take away 20 divided by 2, that's going to be 7, which exactly fits our requirement. So we know that it works, and the answer is 2, We just need two numbers, 27 and 7. Okay, so that's it for this question. And then for question number 21. Alright, so this is a very interesting question. So we have a trapezium right there, yeah? And it says that, let's write down the category of it first. So it's geometry. And I would say it either belongs to split and regroup, or it belongs to cutting up regular shapes. But then you might find it a little bit confusing because a trapezium is definitely not a regular shape. Well, let's say it is part of it, okay? So essentially, we can see that if the base angles of this trapezium are 60, and the top angles are 120, it means that if I try to cut this top angle into half, I will have a triangle that has all three angles as 60 degrees, which means that it is going to be equilateral. Doing the same thing on the other side. And again, I'm getting a triangle with an equilateral, like with 360 degrees, essentially. And how do we know that it is going to be equilateral? That's because it has three equal sides, right? So it means that the top side is equal to that side and it's equal to that side, which means that now all of them are going to be the same. So that might be a little bit small of a diagram. So let me draw a larger one. So because we know that all the sides there are the same, so we can say that this is length, 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 and length, right? Which means that for one trapezium, the perimeter of the smaller trapezium is going to be 5 lengths. And now we can just take a look at this compound large trapezium there. So this side is 3 lengths because that's a top and a bottom, right? Oh, that's a side and a bottom, basically. And that is also 3 lengths, a side and a bottom. That is also 3 lengths, a side and a bottom. That is going to be 6 lengths, 2 sides and 2 bottoms. So altogether, the large trapezium is adding up to 15 lengths, and that's 18 centimeters. So what about 5 lengths, which is the perimeter of the smaller trapezium? That's dividing 3, right? So it's going to be 6 centimeters. If you're just dividing 3 on both sides of the equation, all right? So that's how you can get the answer, 6, right there. So that's it for question 11. As for question 12. So, for this one, it says that, well, in the windows there are some unicycles, some bicycles, some tricycles. We know how many saddles are there in total, how many wheels are there in total, and we know that there are more bicycles than tricycles. So essentially this is a chicken rabbit problem with 3 objects. So it's going to be a little bit more complex. I would say that it either belongs to algebra, saying that it is the indeterminate equations, or you can also put it in the chicken and rabbit problems, all right? I don't actually mind which way you're putting it, because essentially you can say both ways. So, let's say there are U unicycles, B bicycles, and T tricycles. Okay? So, it means that the number of these unicycles, bicycles, and tricycles added up is going to be 7. because 7 saddles means that there are 7 of these cycles altogether, right? And for 13 wheels, we know that a unicycle has 1 wheel, a bicycle has 2 wheels, and a tricycle has 3 wheels. So altogether, that's going to be 13. Now, if I'm taking away the first equation from the second one, what I have remaining is B adding 2t is equal to 6. Now we also know that there are more bicycles than tricycles. So for this indeterminate equation, we can do a little bit of odd-even analysis right there. We know that 2t is definitely going to be an even number because 2 is even and t has to be an integer, right? And we know that 6 is an even number. So what adding even is even? Of course, even adding even is even, right? If I have an odd number, I can't be adding with an even number to make it even. So it means that the number of bicycles has to be even as well. Which means that there can be, for example, 2 bicycles. It means that there are 2 tricycles. Such that 2 adding 2 times 2 is 6. But then now, B is not greater than T because we know that there are more bicycles than tricycles. So 2 and 2 are the same. Which means this is not correct. And when B equals 4, it means that T equals 1. Because 4 adding 2 times 1 is 6. Right? So this time B is greater than T. So it works. And if there are 4 bicycles and 1 tricycle, we can see that 2 adding 4 adding 1 is 7. Right? So it means that there will be 2 unicycles. Alright? So the answer is going to be 2 for this one. And for question number 23. So this one is pretty interesting. I would say that it's counting question on the inclusion and exclusion principle. Of 3 sets. So first of all, it says that we are writing down all these 150 numbers from 10 to from 1 to 150, such that, well, it's in a 10 by 15 grid. That actually doesn't matter. And then we see that all the multiples of 3 are given a red mark. The multiples of 5 are given a blue mark. And the multiples of 7 are given a green mark. How many cells have more than 1 mark? What is this question asking? It is actually asking you that how many numbers have more than 2 factors of 3, 5, and 7. More than or equal to. So it means that these cells with more than 1 mark, the numbers in there must contain at least 2 of these 3, 5, or 7 as their factors. So it is about factors and multiples in a sense. So first of all, we can consider for the multiples of 3 and 5, we know that the lowest common multiple is 15, right? So how many common multiples of 3 and 5 are there? It's 150 divided by 15, which is 10 numbers. So 10 of them are multiples of 15. And we can move on to 3 and 7 with a lowest common multiple of 21. So 150 divided by 21, we can see that it's going to be 7 numbers. That's 147 with the remainder 3, right? So of course the remainder 3 doesn't really matter. I just want to know the quotient, which is 7. And as for 5 and 7, the lowest common multiple is 35. 150 divided by 35, that's going to be 4, because 4 times 35 is 140, with a remainder of 10, which doesn't matter. So we have 4 numbers that are common multiples of 5 and 7. And finally, there's also a possibility that it belongs to all 3 of them, right? It is a multiple of all 3 of them. So the lowest common multiple is 105, which if I have 150 divided by 105, it is 1 number only. So do I just add them up simply? No. Well, the first reason is because I don't have such an answer, right? If I'm adding them all up. And the second reason is because 105 has been counted in all of the 3 lists already. Right? 105 is a common multiple of 3 and 5, so I have counted it once in 3 and 5. 105 is a multiple of 3 and 7, so I have counted it once in 3 and 7. So same goes for 5 and 7, which means that I have counted 105 3 extra times that I shouldn't have. So actually, for the inclusion-exclusion principle, we know that the combined sum is going to be the separate ones removing the overlapping ones, right? So the separate ones is just going to be the sum of all the 4. And the overlapping is going to be the 3 extra times that I have been counting 105 there. So in the end, I have 10 adding 7, adding 4, adding 1, take away 3, which is equal to 19. So we know that 19 numbers will have more than 1 mark on it. All right? That's how we can solve this question 23. And for the next question 24, it is a question about spatial recognition. Well, I think this question is not really much, like a maths question, because there's nothing you can do on calculating it. It is more like a non-verbal reasoning question, because you need to have your spatial recognition skills or like your spatial imagination to solve this question. So I would say that if you can't figure out this question correctly, just there's not much I can help. There's not much I can help because essentially you will have to think about what's going to happen. The next time you see these kinds of questions, it's going to be different, right? So of course, it won't always be the same thing, which means that you need to imagine it again, right? So I would say this question is pretty challenging if you haven't been doing anything like this before. So first of all, we can try to draw a cube. Yeah? Because it says that I need a cube, right? And then it's cut into 2 pieces by a single plane cut, which means that imagine I'm using a knife or like a piece of paper cutting through it, and it's going to be showing as a plane, right? So essentially, how many of these 4 shapes could be the shape of the cross section formed? Which means that if I am putting a plane in this square, which cuts the square into 2 parts, how can the plane be looking like? So for the first one, it's an equilateral triangle, right? And it can definitely come from there as long as you're having 3 equal sides, right? So the first one can work. And as for the second one, you can definitely do that. Something like that. Such that you have an isosceles triangle, which is acute, right? So the second one is also going to work. As for the third one, As for the third one, I might just need another cube for that. So you can imagine that if I am just trying to cut the third one, I will take a short side on the top and the long side down the bottom, such that they are definitely going to be parallel, right? And as long as I can make sure that the two sides are isosceles, that's how I can make my third cut. And then for the last one, it's pretty hard to imagine, to be fair. But the hint comes from the edges. So you can see that it has a top edge, a side edge, and another one, right? So it is a little bit like a large equilateral triangle. So what do we do there? What we can do is try to push that equilateral triangle in such that well, if I am having that cut, something like that cut, or a little bit too big. So if I'm expanding that equilateral triangle until it becomes something like that, it will cut through this face, like exactly like that, right? So probably my drawing is not really precise given the limits there. I will try my best to draw a precise drawing there. So think about if I'm cutting it like this in all three directions. Oops. Yep. Such that the face formed is going to be looking like that. Right? Like this face. So that's how I can obtain the last one of it. Okay, so all four of them works. And sorry, I can't do any more in-depth explanations on this, but that's just essentially how it works. All right. Sorry about that. That's really not something that I can help with, because that can only rely on your own spatial recognition skills and techniques. All right. So I'll try to get around something about these kinds of questions, if possible, trying to help you for these kinds of spatial recognition questions. Okay, and the last one is a trip problem. So you can also say that it belongs to word problems, and it is going to be word problems on meeting and chasing. So essentially, let's say this is Sam starting from Exeter, and this is Morgan starting from London. So Sam is setting off at 10 a.m, traveling 3 hours, and that's 13 o'clock, right? And then Morgan starts at 13 o'clock. So at the time, starting from 13 o'clock, Sam is moving at a constant speed there. Morgan is moving at another constant speed there. That is 35 miles per hour. And Sam is at 25 miles per hour. And for the first section, because we know that for the total time, Sam is traveling an average of 25 miles per hour, right? So we can safely assume that for each section, it is 25 miles per hour on average. And it won't change. Like if it's not, even if it is not, it wouldn't really change the fact that Sam is traveling a fixed distance. All right. So we can just assume that Sam is traveling at a constant speed. So for the first section there, in 3 hours, Sam would have traveled 75 miles, which means that the remaining section is going to be 175, take away 75, which is 100 miles. And because the two people are traveling towards each other, so it would be pretty much the combined speed we are looking at, right? Because both of them are trying to approach each other. So if one of them is not moving, then the other is traveling at 25 miles per hour. But if both of them are traveling towards each other, we should add their speeds up as the total, right? So the combined speed is 60 miles per hour, and they are traveling 100 miles, which means that they would need a time of 100 divided by 60 hours, which is 100 minutes. And what is that time? That is the time after 1 o'clock until they meet. Which means that if I'm adding 100 minutes to 1 o'clock or 13 o'clock, the time is going to be 1440. So 13 o'clock adding 100 minutes. That is 1440. Okay, so that's everything for today's session. I hope you understand what's going on here, and I will see you next week. All right, just let me know if you have any questions, and see you next time. Bye bye.